Okay, first of all, I want to apologize for getting this video uploaded so late. I've kind of had a lot of things happen today. So I would like for you to get 6 colors. I don't know if we'll use all 6 of them for this lecture or not, but just go ahead and grab them just in case we need them. So at the end of this lesson, here are your targets that we're going to cover. So go ahead and take a glance at those to make sure that at the end of this lecture you know how to do those. If not, star one that you don't know how to do so we can talk about it tomorrow in class. Okay, so my favorite unit is the periodic table because the periodic table is everything to chemistry, okay? So far you've been able to identify protons in average mass from the periodic table. Now we're going to take it one step further and talk about the different atoms and how there's different trends involved in the periodic table, okay? But first, we need to talk about the history of the development of the periodic table. And the first guy that we're going to talk about is this guy named Mendeleev, okay? So he first organized the periodic table based off of average mass. Okay? And by mass, I'm talking about by increasing. Okay, so he said that hydrogen weighs 1, so that goes first, helium weighs 4, so that goes second, etc. Okay, so that was the first thing that he did. After he rearranged them by increasing mass, he was able to identify elements that have same properties as well. So not only did he organize it by increasing mass, he also organized it by same properties. What do I mean by same properties? What I mean is if certain elements acted similarly to other elements, he put them in the same group. Okay, so that's the first guy, Mendeleev. He was from 1869. Second guy we're going to talk about is this guy Moseley, which I have a picture of right here. Okay, he took Mendeleev's idea. So then Mendeleev, since he ordered them increasing mass, Moseley came along and said, hey, there's something different here that we need to take into play, and this is the atomic number, okay? So Moseley said, let's rearrange the atoms by increasing atomic number and not atomic mass, and if you look at the periodic table, this is actually the arrangement that we use today. So let's make a note of that. So he rearranged by increasing atomic number, which at this point you guys know means protons, okay? So where is an instance of this? Because a lot of you might still think, well, it's still increasing mass. The one example that I like to give is argon and potassium. So argon weighs 39.95, but potassium weighs 39.1. Argon has an atomic number of 18, and potassium has an atomic number of 19. So that's one of the biggest examples that I give for that. Okay. So based off of Moseley's idea of the periodic table, we were able to develop this periodic law, okay? And it's based off of how the elements are grouped because of their atomic number, okay? So let's look at this. It says that when elements are arranged in order of increasing atomic number, there is a periodic trend. That's where the periodic comes from. A periodic pattern or trend, make sure I spell pattern right, in their physical and chemical properties. Okay, and this is why we call it the periodic table of elements, because the pattern that develops when the atoms are in order based off of their increasing atomic mass. Okay. So let me keep going here. We'll go over a lot of this in class tomorrow, but I just want to kind of rock and roll through these notes, okay? So the way that we set up the periodic table, we have rows, which we call periods or a series, Okay, and so this is the horizontal row of the periodic table. Okay, and then the groups are these guys that go up and down. So this is the vertical rows, or the vertical columns, since they're going up and down. Okay, so let's then talk about what kind of different properties, if they're in the same row and if they're in the same group, what does that mean about the elements and this periodic pattern that holds true, okay? So elements in the same group, so our columns, are going to have very similar properties. So let's make a note of that. And we'll talk a little bit more about these groups here soon, okay? So calcium and magnesium are in the same group, therefore they will have similar properties. Elements in the same period do not have similar properties, okay? And they're numbered 1 through 7. Okay, the groups are numbered 1 through 18. Elements in the same period are numbered 1 through 7, and their properties do not exist, or their properties are not the same, I'm sorry. However, based off of electron configuration, which you know how to do, their electrons will be in the same energy, right? Because the S and the P will be in the same. So let's make a note of that as well. The electrons will be in the same energy level. Okay? So elements in the same group, similar properties. Elements in the same period, not similar properties, but their valence electrons will be in the same group. Okay? So that's the first thing we're going to talk about. The next thing we're going to talk about is what we call these different groups of element. Okay, so this is on page 87. The first thing that I want to talk about is blocks, where how we name these. So you know where the S and the P blocks are, right? So the S blocks is right here, and the P blocks are over here. And these are actually called the representative elements. And I bet you could probably figure out why they're called the representative elements. This is because they hold our valence electrons. Okay, so they represent the electrons that do the chemistry in reactions. Okay, the D block is called the transition metals, where the F block is called the inner transition metals. Okay, so I want you to know that as well. I know I'm going to run over on my next video, so I'm going to stop this video here, and I'm going to upload another one where I'm going to talk about each of the 8 groups that I want you to be aware of on the periodic table.